So we can start a new chapter which is called as a complex numbers. Okay, so let's write. What is the complex numbers? Let's see that one. Okay, so basic concepts of the complex numbers. Under this, what is the first of all, what is the origination of complex numbers? Let's see that once. Normally we will see that there are different types of numbers we call as a natural number, integers, rational numbers, real numbers. So that in that category, so there are numericals which are exist in that case. But whereas come to know in this separate set of integers, separate set of real numbers, it is a combination of x and y. So also called imaginary numbers. So such numbers are said to be complex numbers under this. So especially like come to this concept. For example, if you take x square plus 1 is equal to 0. If you take this equation, so that will become here is, if you comparing with this, ax square plus bx plus c is equal to 0 it is. So that will become a is equal to 1 and b is equal to 0 and c is equal to 1 it is. Then we can take the delta discriminant. If you take here, delta is equal to b square minus 4ac. So delta is equal to b square minus 4ac. By substituting these values here, 0 square minus 4 into 1 into 1 it is. So that is equal to 0 minus 4 will become minus 4, which is absolutely less than 0. So when discriminant is less than 0, the roots are imaginary roots. Imaginary roots are also called complex roots it is. So complex roots are imaginary roots it is. So therefore in this case it is okay. Here is explanation is given is that, as we are saying that x square is equal to x square plus 1 equal to 0 indicates x square is equal to minus 1. So x is equal to, here is root minus 1, x equal to plus or minus I. We call it as x equal to plus or minus I it is. Now coming to this, definition is saying that a number of the form x plus iy. So here is x plus iy is the form it is where x and y are called real numbers. So here x and y are real numbers. I is equal to root minus 1. If you observe carefully, x square is equal to minus 1, x equal to root minus 1 it is. So x equal to plus or minus I we are taking in this case. Therefore this root minus 1 is called as iota. We called as iota it is. That is called as a complex number where I is called iota it is. Now a complex number usually denoted by small z, where we are taking as a z here, and the set of complex numbers is denoted by capital C. It is like this. So capital C like this. So that's why in the form of representation, so z is equal to x plus iy, x comma y belongs to real numbers. So this is the part of complex numbers it is explanation. So therefore remember that when discriminant is less than 0 is the main reason that there is a separate set of numbers has been introduced. Such numbers are said to be complex numbers, also called imaginary numbers. We can remember that, also called imaginary numbers it is. Imaginary. So that's why you should getting that in this case is x plus iy. It is a combination of real part as well as a imaginary part. So next slide we can go to this. So one of the basic concept of the, one of the definition of the set of complex numbers. Now real and imaginary parts of a complex number. Let's see that once here. What is the real part and what is the imaginary part? For example, if you take representation, it is going to be z is equal to x plus iy it is. If you take in the organed plane, let's take this is the point where you are taking, here is x dash and here is x and here is a y here and y dash. So if you take this point in this case is, let's take here is x comma y, and this point will be taking here is 0 comma 0 it is 0 comma 0 it is. So from the 0 comma 0 to the point x comma y it is indicates. So let's take here in this case is origin is shifted to the point P, x comma y it is. So here both real parts will be real numbers are connected here is where you are representing as real axis and imaginary axis. So here is x is the x coordinate, y is the y coordinate it is. Therefore it is a combination of x and y, it is x plus iy. So in this case we are representing this is the form as x comma y it is. Here x is called real number or real part or real number, whereas y is called imaginary part or imaginary number. Imaginary part or imaginary number it is. So real part or real number, imaginary part or imaginary number. So therefore that is a combination of z is equal to x plus iy. We can also write sometimes it is z is equal to minus x plus iy also. So this point will be taking as minus x comma y it is like this. So z is equal to minus x plus iy, that can be representing as minus x comma y, where it is lies in the second quadrant. Here is minus x comma y it is, and in this case is minus x comma minus y it is. Here also in this case it is x comma minus y. But remember that here, okay, so when it is come to negative y, these two things is comes under conjugate of a complex number, that will be discussed later. But before that, only if you are focusing on this x value, x might be positive, x might be negative. So here is the part we can take x plus iy it is might be. So discussing about only real part means it is x might be positive, x might be negative. Now we can go with the explanation part of the next slide. Let's go with. So algebraic operations with the complex numbers. Okay, so what are the algebraic operations? First of all, you might know that here plus, minus, into and the division. So these are called algebraic operations, but with respect to the complex numbers. Let's take first one is, let z1 is equal to x1 plus iy1 and z2 is equal to x2 plus iy2 it is, are the two complex numbers. So z1 is equal to x1 plus iy1, z2 is equal to x2 plus iy2. So let's take the algebraic operations such as z1 plus z2 it is. So z1 plus z2 is equal to x1 plus iy1 plus x2 plus iy2 it is. So then we can take a real part will be added and imaginary part will be added here is. So therefore it will can be written as x1 plus x2 plus I times of y1 plus y2 it is. So sum of the real part and sum of the imaginary parts it is. Therefore it can be taking as x1 plus x2 is the real part and imaginary part will be I times of y1 plus y2 it is. Now this is the z1 minus z2. If you take here x1 plus iy1 minus x2 plus iy2 it is, that can be taken out as x1 minus x2 plus I times of y1 minus y2 it is. So if you subtract the two complex numbers, where you are getting here is subtract of the two numbers of the real and similarly imaginary parts. So therefore x1 minus x2 I times of y1 minus y2. Of course we are to representing in the form point form also. So that will be the x coordinates and y coordinates, x coordinates and y coordinates, like this. Next thing is z1 into z2. Let's see that. So z1 into z2, that can be written as, you call it as x1 plus iy1 into x2 plus iy2 it is. We can use it as a formulas also sometimes. So this can be written as bracket of x1 into x2 and x1 into iy2, it is I x1 y2 plus I into y1 x2, and here is plus into plus I into plus I is a minus I, that's going to be here is minus 1, so that is y minus y1 y2 it is. So here real part and imaginary part will be separated. Here is x1 x2 minus y1 y2 plus I times of x1 y2 plus x2 y1 it is. So therefore you are separating the real part as well as the imaginary part here also. So that is going to be, here is one part is this and other part is this here. Then we can go to this one, z1 by z2 it is. So this is the division of the two complex numbers it is under the z1 by z2. That can be taken out as x1 plus iy1 divided by x2 plus iy2. So how to solve this one? That can be rationalization concept, we can use it here to solve these complex numbers. So therefore x2 minus iy2 divided by x2 minus iy2 it is. So here if you take an idea to express this one is, first of all a plus b into a minus b under the denominator, it is a square plus b square it is. So x2 square plus y2 square it is, x2 square plus y2 square it is. Now if you multiply them, x1 into x2, x1 x2, x1 into minus I y2 it is. So minus I x1 y2 and plus I y1 x2 it is, I y1 x2 it is. And then here is plus into minus minus, so I square will become minus 1. So minus into minus plus it is, that is plus y1 y2 it is. So therefore we can written as here, separating here real part and imaginary part, x1 x2 plus y1 y2 by x2 square plus y2 square plus I times of x1 y2, but here is the negative will be there in this case, minus x1 y2 plus and y1 x2 it is. So y1 x2 divided by x2 square plus y2 square it is. So this one it is. So minus x1 y2 plus y1 x2 divided by x2 square plus y2 square. So hence this is a real part and this is called imaginary part it is. So therefore here four operations are said to be algebraic operations under complex numbers. So number 1, number 2, number 3, number 4. Suppose there is also 5, fifth one it is some constant. K is any constant taking as, so suppose K is any constant it is, any constant is multiplied by, okay, so multiplied by it is K times of z it is. If you take K times of z, this will be taking as K times of, let's say x plus iy suppose. So that will be kx plus and iky it is comes under. So kx plus I times of ky it is. So therefore it is said to be k is any constant which is multiplied by real part as well as the imaginary part, then automatically changes in the both the parts you called as real numbers as well as imaginary numbers, right?